We're getting somewhere. We're over halfway done by the end of tonight, which is pretty exciting. And last week, if you weren't here, we talked about the fossils, the billions of dead things buried in rock layers laid down by water all over the earth. And I came across another bad joke, so I feel obligated to share it with you, okay? This one's about fossils. It's real short. What do you call a fossil with no body? A bonehead. Told you it was bad. Some of y'all might live with a couple of those. I don't know, but anyway. Yeah, but let me show you a quick video review, 2 minutes from Answers on Fossils. Here we go.
Dead organisms usually don't last long. Scavengers and bacteria consume them quickly. Soft tissues rarely last more than days or weeks, and hard parts like bones or shells only a month or two. But the rocks of Earth contain billions and billions of fossils, and in many places, millions of fossils are exquisitely preserved, even soft parts. How could this be? To preserve a body, it needs to be put in a safe place. Extremely cold or dry places would protect them, but most organisms don't live in those conditions. There is another solution: rapid burial. If a body is sealed from oxygen and out of reach of burrowing animals, then it has a good chance of fossilizing intact. Rapid burial is uncommon today, but there's much evidence of massive burials in the past. Not only are many fossils well preserved, they're found amidst very fine sediment layers. Fine layers rarely last in the present because all sorts of animals are digging around in the mud and soil, searching for food. In just a few weeks or months, the original layers are destroyed. But in the fossil record, churned up sediments are rare. If these sediments were laid down rapidly, however, they'd prevent burrowers from doing their job. And there are thousands of feet of such layers in the fossil record all over the world. This suggests that moving water laid down mud and sand rapidly over a wide area, and the process lasted several months. A year-long global flood, as described in the Bible, is the best explanation we know for the well-preserved fossils and fine layering throughout the rocks of the earth.
Okay, that's a good summary video, and once again, if you missed the class, you can go back and check it out online. But as we've seen over the last 2 weeks, when we take observational science, it confirms the biblical interpretation of the fossils and of the rocks and so forth, and rejects the idea of millions of years. And so we should not be afraid to stand on God's word. And what we're seeing again and again is that if we start with the Bible, we have answers. We're able to give a defense for the faith that we have. And we need those answers not only for ourselves and for our culture and the world around us, but we need them for our children. And if I can hearken all the way back to week number 1, this is why it is so important that we do not teach the Bible as a mere storybook. Because when you do that, you're basically implying that we need to go to another authority, like secular textbooks or secular scientists, to find out information about history. If we teach Noah's flood as merely a story in our homes and in our Sunday schools, if that's what we're teaching our kids, if this is the idea we're giving of the flood to our children, then when they go out into the real world, they're not going to have answers. And this idea is going to be absolutely annihilated by our culture, by the movies they watch, books, TV, teachers, friends, and so forth. They're going to get attacked with ideas like, well, how could all those animals fit on the ark? Or those rock layers were laid down over millions of years. What about the global flood? That'd be impossible. Noah's flood is a myth. Where did all the water come from? Where did it go? Can't you see the Bible's not true? And when they come back to us, when they go back to their Sunday school teacher on Sunday, if we merely tell them, don't worry about that. Let's go on to the next lesson. Just trust in Jesus anyway. It's not going to take them too long to realize, well, if I can't trust the Bible when it talks about history, why should I trust it when it talks about salvation? Do you realize this is actually what happened to Dan Brown, the author of the Da Vinci Code? He's being interviewed, and they asked him the question, are you religious? I want you to notice his response. He says, I was raised Episcopalian, and I was very religious as a kid. And then in the 8th or 9th grade, I studied astronomy, cosmology, the origins of the universe. I remember saying to a minister, I don't get it. I read a book that said there was an explosion known as the Big Bang, But here it says God created earth and the animals in heaven in 7 days, which is right. Unfortunately, the response I got was, nice boys don't ask that question. And then a light went off, and I said, the Bible doesn't make sense. Science makes much more sense to me. And I gravitated away from religion. In his book, Already Gone by Ken Ham and Brett Beamer, they studied the issue very closely of why so many professing children are walking away from their faith. If you remember from week number 1, the average is 70 to 80% of professing Christian kids walk away from their faith 1 year after high school. So they did a lot of extensive polling on the matter, interviewed a whole lot of people, and they asked some questions, a whole lot of kids, and said, at what age did you begin to really question the contents of the Bible? I want you to notice middle school, and then high school. Notice college wasn't that big of a deal. You know why? The seeds were already planted. College is just where they showed their fruit. And then it went from questioning to unbelief, which, by the way, that's what the snake did with Eve in the garden. Hath God really said? And once he got Eve to question it, then she started to doubt it and then rebel. But if you don't believe, when did you first have doubts? Notice again, middle school and high school were the two primary areas. And what are the key things they're having doubts about? Age of the earth, too many rules, that's that natural rebellion in us, and then the creation account and the flood. Those were the things that cause kids to question the Bible. And that is why it is so important that we have an answer, not only for the world, but for ourselves and our children. And when our kids come into our Sunday school classes, in our homes, we need to be teaching them the flood account. And I will challenge you to take the word story when you're talking about the Bible out of your vocabulary. When you say the Bible story, it gives this connotation of a fairy tale. And so me and Marla try really hard whenever we're talking about this to say the event of the flood or the flood account. And so when we teach the flood account and we realize when we apply the biblical history to what we actually see in the Bible and to the world around us, we realize that the ark was plenty big enough for all the kinds of animals needed. That the mechanism for the flood would have wiped out and destroyed this world. That same mechanism would have laid down those rock layers and created canyons and buried billions of dead things buried in rock layers, laid down by water all over the earth, just like we talked about for the last 2 weeks. And if we can trust the Bible when it talks about the flood, we can trust it when it talks about Jonah, we can trust it when it talks about salvation. Why? Because it is real history. And that's what we need to be impressing upon our children, connecting the Bible to the real world. And when we use that biblical history, simply put, we have answers. And our kids will have those answers. And hopefully they have the ability to stand firm in their faith in this culture that is attacking their faith from every angle. And Lord willing, grow up and pass on their faith to their children. And again, that is why it is so important that we focus on this issue and have answers for the faith that we have. Quick review, kind of entitled there, kind of combined with everything we've been talking about for the last couple of weeks, and I thought I'd throw it back to week number 1. But tonight, let's jump on to tonight because we got a lot to do tonight. If you looked at your handout, you might be scared. That's understandable. We'll get to that here in a second. But 3 weeks ago, or on week number 3, we talked about the age of the universe and where this idea of millions of years actually came from. And we saw that if you start with the Bible, that according to the Bible, the earth is roughly around 6,000 years old. And of course, secular scientists date the earth around 5 billion and the universe around 15 billion. And again, we shouldn't be scared about that. They all have the same evidence. We've said this numerous times. And they just interpret it differently based on their different assumptions, their different philosophies. And this is particularly true when you talk about historical science, because you got to look at the stuff in the present, use your assumptions about how things operated in the past, and come to your conclusions. And we saw on week number 3 that the idea of millions of years did not come from any new evidence, but from a new worldview. Late 1700s, James Hutton, naturalism, uniformitarianism, popularized by Lyle. If you didn't see week 3, you should check it out. And the Bible warns us about this. Colossians 2:8. It's a verse you keep seeing on the starting slide. It tells us that, see to it that no one takes you captive through hollow and deceptive philosophy, which depends on human tradition and the basic principles of this world rather than on Christ. You can read into that uniformitarianism and naturalism. It fits right on in there. And then the summary point from week number 3 was this. Evidence for deep time, or millions of years, is only produced by selecting specific observations. That's what we're going to talk about tonight, assuming uniformitarianism and believing naturalism. Now, week 3, and I really think over the last 6 weeks, we've really dealt with uniformitarianism and naturalism, talking about those things. Tonight, we're going to look at the other observations, because most observations tell us that the earth is not that old. Over 90% of the different dating methods you could use to get an age for the earth give an age of much less than 1 billion years. much less than what secular scientists tell us, and much too few to actually have time for evolution. And what we're going to do tonight is look at all those other observations you don't hear a lot about. And so what I want you to keep in mind as we look at all these observations, a couple of things. Number one, the things we're looking at put upper limits on an age, not lower limits. In other words, we'll look at a process that's occurring today, and we'll say if it's always occurred at this rate, the Earth could be no older than 5 million years old, or no older than 62 million years old, or so forth and so on. It doesn't mean the Earth is 62 million years old, it just means it cannot be any older than that. They put upper limits. They don't put lower limits. And then once you include the creation account and the flood, you make up the difference. It's not that hard to do. But we're focusing on the things that put upper limits. And what we're essentially going to do is use secular scientists' own assumptions against them. I like this quote from John Morris, his book, The Young Earth. Very good book, by the way. And this is what we're going to do tonight. He says, we can use the set of assumptions employed by old Earth advocates and demonstrate internal inconsistencies in that way of thinking. When we do that, the weight of the evidence, even using their own assumptions, points to a young Earth. So we're going to show, even using their own assumptions, the evidence points to a young Earth, and how inconsistent uniformitarianism is. And if your assumption is inconsistent, you might want to get a new one. Maybe like biblical history is true. That's what I would suggest. And if you looked at your handout, you probably got scared. You saw a list very similar to this, and again, I'm just showing that for dramatic effect. We are not covering all of those, nor are we going to cover everything on your handout. That's important to realize. What I did is, I used to teach 2 classes on this particular subject. So there were 2 full-length, full hour-long classes about all the different evidences for a young Earth. And we did 1 class on evidence from space and 1 class on evidence from Earth. And since we're only doing 1 class this semester, I kind of took some of my favorites and put those in this particular presentation. But what I did for you on the handout is I just put all of them. Those are all the different ones we cover in the old class. There's a whole bunch of other good stuff in there. Some of it is really, really good, but we just don't have time in this particular setting. So you can kind of skim through that if you get a chance. And if something else, catches your fancy as you're skimming through it, you can check that out on your own. So I understand we're not covering all of that. With that being said, we are covering a lot. And so that means I'm going to go fast, which I know that's not a surprise. That's the norm. I get that. But maybe even a little faster than normal, which is scary. But I'm going to try to pronunciate really well. And my goal for you is this. Buckle up, hang on, and we'll get through it together. There's a lot of good stuff. And in the end, if you need to see it again, that's why it's online. That's a beautiful thing. All right, but hopefully it'll be good tonight. But we're going to cover a whole lot of stuff. All right? Here we go. Evidence from space. And this is all evidence pointing to a young Earth or young universe. First, let's talk about galaxies. And of course, galaxies are absolutely beautiful. They're gorgeous to look at. The first thing we need to remember about galaxies, though, is that according to evolutionists, they have no idea how they form. I just love this quote right here from an evolutionist who says, there shouldn't be galaxies out there at all. And even if there were galaxies, they shouldn't be grouped together the way they are. We'll get to that here in a second. It's one of the thorniest problems in cosmology. It's hard to convey the depth of frustration this simple fact induces among scientists. They don't know how they form. They're frustrated by that. But if you look at many of these galaxies, you'll notice a distinct spiral arm structure from the rotation of the galaxy itself. Well, the thing you need to realize about this rotation is that the inner stars actually rotate faster than the outer ones, which begs the question, why are there still spiral arms if the galaxies are millions of years old? Because just within a couple rotations, the spiral arms will be blurred together to form just a featureless disk. That would happen in just a few million years. The fact that they still have spiral arms implies they're still relatively young. And actually, if you look at this online, if you try to find some information about why there are spiral arms, some evolutionists will argue, well, maybe we could explain it with spiral density waves. And you can check that out if you want. But it's just a guess to try to explain away the evidence. And by the way, I threw that in there to just give you a heads up. All the stuff I show you, if you go and research it, you'll see the evidence, and then you'll have scientists give you a plausible explanation trying to explain away why it is the way it is, which that's what you would expect them to do. They're defending their worldview, I understand. But most of their hypotheses cannot be tested, and they cannot be observed. That's a key thing to keep in mind. But as we look at these galaxies, not only should they not have spiral arms, but we find them clustered together. It's absolutely amazing. And actually see the bend of some of this light. Gravity actually bends light, which is a cool thing different story. We can't get to that now. But we see galaxies in clusters, and we see stars in clusters. Absolutely phenomenal to look at. They are beautiful. But the thing is, for the evolutionists, this is a problem. You see, these stars and these galaxies are moving. They're rotating. Actually, these clusters are like swarms of bees, and they're held together by gravity. But gravity should not hold them together for more than a few million years. So the question is, if these clusters of stars or clusters of galaxies are more than a few million years old, why are they still together? They should be spread out by now. We talked about a couple weeks ago how we haven't actually seen a star form, the actual formation, the actual nebula hypothesis where the cloud breaks down and collapses on itself. We don't see them form, but we see them blow up about every 30 years. And if a star blows up about every 30 years, if they've been around for billions of years, we should see millions or billions of supernova remnants. How many do we see? I don't know if you remember the number, but it was 205. It's about 6,000 to 7,000 years worth of supernova remnants, which is pretty cool. Moving right along, blue stars. Blue stars are a problem for old Earth people because blue stars burn really, really, really hot, really intensely. That's why they're blue. And they should not last that long. The problem for the evolutionists is we find blue stars everywhere in practically every galaxy, galaxies that are supposedly billions of years old. Well, these stars should not last past a few million years, yet they're still everywhere. And I love 1 Corinthians 15:41 in referencing the blue stars. It talks about different stars having different glories. Right there in 1 Corinthians 15, you should check it out, it's pretty cool. And then the issue of solar wind and solar drag. Now with solar wind, here's what happens. The sun's radiation applies an outward force. So what should happen is tiny particles that are in our solar system, in particular tiny particles that are around the sun, should be blown out away from the sun and out of our solar system. Just to within literally a few thousand years, but they are still abundant and they're still orbiting the sun, which should not be the case. Not only that, but then you have the issue of solar drag. And this is the issue of the sun's gravity pulls in the bigger particles, the micrometeors. So it pulls in and consumes the big stuff like a huge vacuum cleaner, blows out the small stuff. So all the particles, the micrometeors, should be gone within 10,000 to 50,000 years. But they are still here in abundance, and there's no known source of replenishment. They're still here. And we see this in practically every galaxy we can observe. There's a lot of dust. It's a dirty place. It shouldn't be that way if it's been around for more than a few thousand years. And I do want to touch on this fairly quickly. How many of you have ever heard the argument that since we can see light from stars that are billions of light years away, that proves that we're billions of years old? Who's heard that? Okay, a few of you. It's kind of, what I want you to notice is you have the same assumptions in that dating method as you do with radioisotope dating and any other dating method. Here's the argument. There are some stars that are really far away. Let's say 5 billion light years away. And a light year is a distance. It's essentially how far light will travel within a year. So if a star is 5 billion light years away, that means light, even traveling at the amazing speed of 186,000 miles per second, would take 5 billion years to get from that star to the Earth. And the simple argument goes, well, if we can see light from that star, and that star is 5 billion light years away, then we must have existed for at least 5 billion years for the light to get here. Pretty straightforward. But I want you again, and we've seen this a couple of times, but notice the unspoken assumptions behind what they just did. First of all, number one, you have to assume that the rate of light has always been constant and that the conditions have always been the same. You have to assume uniformitarianism. Sound familiar? Next, you have to assume there's been no divine intervention, that God did not make the universe, that there was no special creation involved at all, which is the religion of naturalism. Still sound familiar? It should. And then, of course, in the end, you have to assume that the Bible is wrong, so this is not a neutral position. So you have the same unspoken assumptions behind this particular way of dating things as well. Plus, what I find intriguing about this particular problem is the idea that people who believe in the Big Bang in billions of years have the exact same problem. It's called the horizon problem. It's fairly interesting. It goes a little something like this. According to the Big Bang, after the Big Bang, different regions within the universe would be at different temperatures. But as we look at the universe today, the universe is amazingly uniform in its temperature. It's all the same, everywhere you look. And the only way to get it to all be the same temperature is you need to exchange heat. The quickest way to do that is through light. It's the fastest mechanism we got. But the universe is so big that there's not been enough time, even within 15 billion years, from light to get from this region to this region. So big bangers have still the exact same problem of not enough time for light to travel from one region to another. Just kind of cool. Then you got this. Planets are cooling down, which makes sense. Things like Jupiter. Jupiter loses twice as much heat as it gains from the sun. Now here's the problem. It doesn't generate heat by itself. It has a limited amount. Second law of thermodynamics, things run out over time. It's just what happens. So if Jupiter's been around for 4 or 5 billion years, it should be stone cold by now. It's still really hot. You have the same issue with Neptune. Neptune is still very warm. Not only Neptune, but then Saturn, Uranus, Venus, they are all way too hot to be billions of years old. Very consistent with the idea of 6,000 years, not with 4.5 billion. Just like when you take a cup of coffee and you set it on the coffee table, loses heat over time. Who in here hates lukewarm coffee? Can I get an amen from somebody? Okay, I can't stand that stuff. But that's what happens. It loses heat. The same thing with the planets. Your coffee just doesn't, magically get hotter by itself. It'd be kind of cool if it would, but that doesn't happen. So the same thing happens with the planets. You got the same issue with Jupiter's moon, Io. It is extremely hot, has extremely active volcanoes shooting huge plumes into the atmosphere. According to the evolutionary model, it should be stone cold. Jupiter's moon, Ganymede, has a really strong magnetic field, which implies a liquid core. And again, if it was billions of years old, it should be stone cold, especially since it's smaller. Or what about Jupiter's magnetic field, which is gigantic? The magnetic field of Jupiter is about the size of the sun. It's huge. And the thing is, if it was actually billions of years old, it should be very weak by now, if pretty much non-existent. But it's still here, and it's still really, really strong. You probably read it already. This is pretty cool. Dr. Russell Humphreys correctly predicted the strength of Jupiter's magnetic field before anybody got there, based on the idea that it was only 6,000 years old. And that's really cool when you can make a prediction, then that is confirmed by observational evidence that really confirms your starting assumptions, which is what he did. And I believe we talked about comets already, but short period comets shouldn't only last but 10,000 years. Even the bigger comets shouldn't last more than 100,000 years because they're just mud and ice. That's all they are. They're constantly losing matter, especially when they go around the sun. So, if they shouldn't last past 100,000 years, then why are there still comets all over the place in our solar system? They're everywhere. Well, what the evolutionists tried to do is they hypothesized this thing called the Oort cloud. There's a guy named Oort, and he said, well, maybe there's this cloud outside our solar system that's kind of like a dwelling place for all the comets. And then once in a while, a meteor comes along, goes into the cloud, knocks out a comet, and it goes into our solar system. The problem with the Oort cloud is that it has never been observed. Never. I like this quote from Carl Sagan, a very famous evolutionist. He says, many scientific papers are written each year about the Oort cloud, its properties, its origins, its evolution, yet there is not a shred of direct observational evidence for its existence. I've heard it put like this. Some scientists will argue, yeah, but you can't disprove it. And that's true. It's pretty hard to disprove something you cannot observe in any way. That's kind of a tough thing to do. Or how about this? Did you realize we're losing the moon? I know it's sad, it's going away. But don't worry about it. There's not much we can do about it, and it's not that big of a situation. It's going away about 2 inches every year. Just a little bit. So you go back 6,000 years, that means if it's moving further away, in the past it used to be closer, right? Good. Who can figure that out with no help at all? Okay, some of y'all are still confused. Maybe I need to slow down a little bit more. Okay, no, so it's moving away. It used to be closer. 6,000 years ago, not a big deal. But you go back a few million years, it would have been so close. Remember, the moon causes the tides. The tides it would cause would destroy the earth twice a day. It's been scientifically proven only once a day is enough. All right, so that would be really bad for the earth. Not only that, but if you keep going backwards just 1 billion years, the moon would have actually ran into the earth, which is not good. But if you believe this theory, that might explain what happened to the dinosaurs. They got mooned. That's Marla's favorite joke. I'm telling you, that's her favorite. But speaking of the moon, this moon, just a cool little side fact. Did you realize that the moon is 400 times smaller than the sun, but the sun is 400 times further away? According to the Bible, what is the purpose of the sun, the moon, the stars? What are they for? They're a giant clock, right? Exactly, they're a giant clock. It's interesting that, of course, eclipses are used for time markers, and the moon is perfectly situated, perfectly sized to be a full eclipse of the sun as a time marker. Just a cool little side note. And actually, if we look at the Bible, it's really cool. The universe constantly confirms the Bible. And the Bible makes all these correct observations about the universe before science had any idea. Things like this. Do you realize the Bible says the earth is round? A couple of different places. The Bible also tells us that the earth floats in space, that it hangs on nothing, which is exactly what it looks like, isn't it? Of course, the Bible said that long before anybody else had any idea about that. The Bible also tells us that the universe is expanding. The Bible says over 20 times that God stretches out the heavens. He stretches out the heavens. We know now today that the universe is expanding. And actually it's probably the cause of the red shift we see. The Bible knew that way before anybody else found that out. It's really neat. Of course, you would expect that from the Word of God. It talks about the conservation of mass and energy, that God created everything during the special time of creation. Then he stopped creating. Now we have the first law of thermodynamics. Nothing is created or destroyed. Matter stays the same amount, which is the conservation of mass or energy. You see that in a couple of different places. Also, the number of stars. Back in the day, guys thought you could count them. 1, 2, 3, 4. They got different numbers, like 1,000. One guy was really spiritual. He had the number of 777. All right? Of course, the Bible said way ahead of time that you cannot count them. Man can't count them. But God knows them by name, which is a pretty cool thought, too. But they knew that. The Bible knew that before science had any clue. And then the idea of the ordinances of heaven and earth, the laws of nature that God put into place and he holds together. The Bible teaches all that, and that's what we observe today. Now, what about evidence from earth? Evidence from earth. We're actually making pretty good time. Am I talking way too fast? That's maybe a really dangerous question to ask, but okay, good. I got no amens. All right. Evidence from earth. First, let's talk about the magnetic field. This may be the best application of uniformitarianism principles, the absolute best one, because we measured it for a really long time, over 170 years now. It's declined 10% in the last 150 years, and it's been measured all over the world, so we know it's very consistent. And if you go back, if it's weaker now, that means in the past it used to be stronger, right? You go back 7,000 years, it would have been 32 times stronger than it is now, which would be really good for us, actually. Much more protection from the sun, so forth and so on. It would be good. But if you keep going backwards in time, just 20,000 years ago, it would be so strong that it would liquefy the earth. I think that's a bad thing. I don't know, but you know. But anyway, we've measured this for over 170 years now. Very consistent. The best application of uniformitarian principles, and it points to Earth of only thousands of years old. Pretty cool. The Earth is spinning. Who knew that already? Yes. All right. Yeah. Spinning like 1,000 miles an hour at the equator. But we are slowing down. Just basically, what you're seeing here is the second law of thermodynamics over and over again. Things wear out over time. They lose heat. They lose energy over time. The Earth is slowing down. There was an article in Astronomy magazine that said the Earth's rotation is slowing down. To compensate for this lag, in June, there'll be a leap second. And they gave a whole list of different leap seconds. So if it's slowing down, that means in the past it used to be spinning faster. You go back 6,000 years, not that big of a deal. Spin a little faster, wouldn't really affect life. You go back millions of years, again, that might explain what happened to the dinosaurs. That's a new slide, too. I'm happy about that. We'll watch that again. Okay. This one is one of my favorites. Carbon-14. Who has heard, maybe at some point in your lifetime or just somewhere, sometime, that carbon-14 proves the Earth is millions of years old, therefore it's millions of years old? Okay. The funny thing about that is carbon-14 cannot be used to date anything past 100,000 years. That would be problem number one. We'll get to that here in a second. But here's how carbon-14 is basically produced. We don't need to know all the ins and outs, but I'll give you the basic breakdown. We have cosmic rays coming into our atmosphere. They run into nitrogen-14. Knocks off a proton, gives it a neutron, it becomes carbon-14. That carbon-14 hooks up with some oxygen, becomes a form of carbon dioxide. So what happens is that carbon dioxide will then, of course, go into plants. Animals then eat the plants, and of course, we ourselves eat the plants, we eat the animals too, other animals eat animals. So all organic life forms have carbon-14 in them. They just do. It's in there. Now, carbon-14 is unstable, which means it breaks down over time. It wants to go back to its original nitrogen-14. That's its goal. And so when the animal dies, it stops taking in carbon-14. So the carbon-14 that is inside starts to break down. So basically, when you look at a fossil, when you find an organic remain, coal, fossils, whatever, you can look at it, see how much carbon-14 is left, and get an age for the animal, roughly. That's how it works. Here's the thing about carbon-14, though. It has a very short half-life. Its half-life is 5,730 years. That means when an animal dies, within 5,700 years, half of the carbon-14 in that animal, in that fossil, will be gone. And then after another 5,700 years, half of that carbon-14 will be gone. And basically, within about 50,000 years, you can hardly detect any. Within 100,000 years, you cannot scientifically detect any carbon-14 in that organic remain. So here's the thing. If these fossils in the rock layers that are supposedly millions, and as you go deeper down, supposedly hundreds of millions of years old, if they are actually that old, you should find absolutely none, zero, nada carbon-14. If the whole Earth was made of carbon-14, it'd all be gone in a million years. We should find no carbon-14 in any of these fossils. Guess what we find? In every organic remain, in every single rock layer, there are measurable amounts of carbon-14, putting the age of all these layers, all those fossils, all those organic remains, in the age of just thousands of years, not millions. One of the best evidences for a young Earth. And there are all kind of really intriguing answers about how that carbon-14 got there from evolutionists, but it's there and it's a big problem for them. Actually, the RATE group, this is a bunch of creation scientists who got together. They knew this fact, so they actually wrote a book called Thousands Not Billions, another very good book. And so they started looking for carbon-14 in certain places. For example, in coal. So they took 10 coal samples from 3 different periods in the fossil layers: Cenozoic, Mesozoic, Paleozoic, which sounds really fancy, but Cenozoic is just recent life towards the top. Mesozoic, middle life, so it's in the middle. Paleozoic, ancient life, so it's towards the bottom. They took coal from all of those labels, had it tested for carbon-14, and every single one of them had measurable amounts of carbon-14, putting the age of all those coal samples, some of which, according to evolutionists, are hundreds of millions of years old, at no more than 50,000 years old, a max age. Then they got really ambitious. They said, well, if it works with coal, what about diamonds? Because they have an organic origin as well. Now, diamonds are supposedly billions of years old. So they took 12 different diamond samples, checked them out, and lo and behold, they still had carbon-14. And you cannot contaminate a diamond. It cannot be penetrated by mud or anything like that. So the carbon-14 that's in there is original to itself. Great evidence that all those diamonds are just thousands of years old, not billions. Then we got things like this: meteor craters and rocks. You realize that meteors and the meteor rocks and the craters are normally towards the top of the layers? We don't typically find craters or rocks in the lower layers. Don't you think if this layer down here was 500 million years ago and it hung out for 100 million years, that there might be a meteor hit it every now and again? Leave a meteor, leave a crater. We don't find any of those. They're only at the top. You know why that is? All those layers were laid down quickly by the flood. And the craters we find and the meteors we find hit after they were laid down. Also, in that same line of thought, talking about the flood and its effect, sodium. Of course, you have constant erosion. We get about 450 million tons of salt being eroded into the oceans every year. Only about 120 million tons leave it every year. So the sea is always filling up with salt. Well, according to evolutionists, the ocean is around 3 billion years old, roughly. So if that's been happening for 3 billion years, there should be a lot more salt than what we have. The amount of salt we have in there now could have been accumulated in just 62 million years. And of course, you count the flood, special creation. God made the ocean with some salt in it already. No problem at all for the creationists. Or how about this? As the continents are continually eroding, at today's rate of erosion, the continents would erode flat in just 14 million years. You know what that means? What would be washed away if the continents were eroded flat? I got a guess? Starts with an F, ends with ossel. That's right. I love doing that. I do that with my kids all the time. Yeah, the fossil record will be eroded away in just 14 million years. and it'd be eroded away over and over and over again, but yet it is still there, implying it's just not that old. Not only that, but of course, as the erosion continues, it carries dirt into the ocean. And there's only an average of around 400 meters of dirt in the ocean. That could have accumulated in less than 14 million years. There should be a whole lot more dirt. Actually, it should be 60 miles to 100 miles thick, so I guess the oceans will be full of dirt if they're really billions of years old. And then just one little last thing about the ocean. As it carries not only salt, but it carries all the other elements as well, and dirt, and all kinds of junk. And literally, in just millions of years, the ocean should be a toxic waste dump from everything that's being poured into it through erosion. And of course, it is not. Great evidence that it's just not that old. Or how about this one? Oil pressure. Do you realize that this oil pressure right here can be up to 20,000 pounds per square inch? The rocks can't hold that pressure that long. The guesstimate is around 10,000 years. So why do we find oil under pressure everywhere we go? You know, when you drill down, of course, it explodes up. Why is that? Because it hasn't been there that long. That's why. Or, what about human fossils? See, according to the evolutionist theory, man comes onto the scene. He's your Homo erectus or whatever around 1 million years ago. We'll get into that later on. And he's been around for a really long time. So if man's been around for millions of years, then there should be billions upon billions of human fossils, human skeletons all over the place. We can only find a few thousand. There should be a lot more if the earth is millions of years old and evolution is true. I like this one. This one's kind of cool. Population. Do you realize if you took 8 people at modern growth rates, go back 4,400 years and had them start refilling the earth, by the year 2000, you expect to get 6 billion people. That's pretty cool, because that's exactly what we had at the year 2000. On the flip side, if you take one couple and go back just 41,000 years and have them start repopulating the earth, you get a number of 2 times 10 to the 89th power. That's something like 150,000 people per square inch. It's going to be kind of crowded, all right? Would not be a good thing. Or how about this? Historical records only date back to around 5,000 years ago. And the civilizations are highly developed. The languages, the writings, the cultures are complex and fully developed. I have a question. Why are the oldest reliable historical records less than 6,000 years old? I got a theory about that. You're right. I'll come back to it here in a second. Let's go to this one. The Sahara Desert. Anybody know what the word Sahara actually means? Yeah, it means desert. Who named it? The desert? Really? All right, but anyway, that's ADD. Sahara Desert. It grows by prevailing wind pattern. It's called desertification, and you can measure the rate at which the desert grows. So we measured the Sahara Desert, and we figured out that, well, due at the rate it's occurring today, the Sahara Desert is only around 4,000 years old. Question. Why is the oldest desert in the world less than or right at 4,000 years old? I got a theory. Here's my theory. I think 6,000 years ago, God created everything. 4,400 years ago, there was a flood. And you got to admit, it'd be hard to have a desert during a flood. Then after the flood, a few hundred years later, a desert starts to form. We get a desert around 4,000 years old. Or how about this? The largest coral reef in the world, the Great Barrier Reef. Anybody ever been there? Just curious. Okay, I really want to go there. But anyway, the coral reef, the Great Barrier Reef, largest one in the world. In World War II, part of the reef got destroyed. And so for 20 years, a group of scientists went out there and watched the reef grow back. It was a government project. It probably did, you're right. They watched it grow back for 20 years, and they said, you know what? At its rate of growth, this whole reef could have been formed in just 4,200 years old. In 4,200 years. Why is the oldest coral reef just 4,200 years old? I got a theory about that. Here's my theory. I think 6,000 years ago, God created everything. And 4,400 years ago, there was a flood. Wiped out everything. Coral reefs started growing after that. That's what you expect to find. Or check this out. The second oldest trees, the sequoias in California. Now, I know some people went and saw the Grand Canyon. Anybody see these? Are they amazing in person? Seems like they would be. Here's your tree hugger right there, literally. But there's your person for scale. These things are huge. As a matter of fact, they're so big, they have no natural enemies. None. The only thing that can really wipe them out is man. Fires don't take them down. Bugs can't take them out. They're too strong for that. So question, Why are sequoias never older than 4,000 years old? I got a theory about that too. But before we get to that, or how about this, the oldest living organism, called the bristlecone pine tree, guesstimated to be around 4,300 years old. I have another question. Why is the oldest living organism 4,300 years old? I bet you can figure it out by now, right? Yeah. As you notice, the more we look at all these things, the more we realize that the Bible is true. Again, over 90% of these things point to a very young earth. Why don't you ever hear about these things? We'll get to that here in a second. But again, what we've noticed, going back to that quote originally, is that when we take secular scientists' own assumptions, we see their internal inconsistencies. Not only that, but using their own assumptions, it all points to a young earth, even using their own starting points, which is absolutely awesome. But why don't you hear about it? Real simple. Like we said on week number 3, time is a hero. Time itself performs the miracles. Got to have those millions of years. And so this leads to the last question we're going to address tonight, which will be this. How could so many smart people be wrong? You ever thought about that? Raise your hand if you thought about that. Yeah, because some of these guys are absolutely brilliant. And I think there are multiple things we could say about that. I'm going to say a few things tonight. The first one is, not only are they wrong, but they're blatantly and confidently wrong, right? I mean, evolution in millions of years is propagated as absolute fact through basically every media imaginable, isn't it? They're so confident. But you can be absolutely confident about what you're doing, but still be off the mark. Right? You can be confident, but be off the mark, which reminds me of a really low point in my life that I need to tell you guys about. Me and Marla were getting our master's from Lee University. This a few years ago. It's actually been, 9 years ago. Anyway, and so we're getting our master's, and we had a class that was where we had to teach a lesson. And so I was going to do my lesson on passing a basketball. Some of y'all might know I played a little basketball, some college basketball back in the day, and so pretty good at it. I'm familiar with it. I thought it would be an easy thing to do. So here was my lesson. I was going to get all the people to stand in a circle around me, all my classmates, and they're all different ages. Some just out of undergrad, some are changing vocations. And so they're all in a circle around me. And I would pass them the ball and call out the pass, two-hand chest pass, one-hand pass, bounce pass, whatever. And then they would do it back to me, and then I'd go around the circle. This was my lesson. So I've got the ball, and it's a basketball. We're in a classroom, and I'm throwing these passes to different people. And I get to the professor. And me and him had a pretty good relationship. He was kind of the guy, he liked to joke a lot. He played basketball, too. So when I threw him the ball, he caught it and threw it back at me really, really quickly, trying to get me. I said, oh, okay, I see how it is. I made a little mental note of that. And so as I continue around the circle, I thought, I'm going to catch him off guard. I am going to take this ball. When someone throws it to me, I'm going to whip it around my back, no look around the back, passing him right in the chest without him even realizing what happened. And I was fully confident in my ability to do this. I had thrown this pass who knows how many times in my life. I mean, I'm a college basketball player. I got this covered. So I'm going around. I get to this person. I can just barely see him in my peripheral vision, right? So here's the time. So they throw the ball back to me in one beautiful, smooth motion. I just sling it around my back. And I throw it hard because it has to catch him off guard. And so as it's going around my back, I lose control of it just at the very end, which is not good. And so the pass veers up and left and hits a very nice grandmotherly figure right beside him, square in the head. I'm talking, I almost knocked her out. Nobody knew what was going on. Marla was so proud. And so no one knew why I threw the pass. No one had any idea what was going on. She's on the ground crying. I mean, literally, it was awful. It was one of those things where for the next 3 or 4 weeks, every time I thought about it, my stomach knotted up. You ever had one of those? Oh, man, it was terrible. And you know what? I mean, I was confident in my ability. I knew I could make that pass. I had no doubts, but I was wrong. I was off the mark. And, I think the same can be said for a lot of secular scientists. They're so sure they're right because they've been taught this from their teachers, and their teachers were taught this from their teachers. But it's not, but they're still confident in it. So just because you're confident in what you're thinking doesn't mean you are right. Which also reminds me of another little story about Muhammad Ali, who was on an airplane one time and there was turbulence on the airplane, and the pilot said, put on the fasten seatbelt sign. And so the stewardess is going up and down the aisle. Everybody has on their seatbelt besides him. She comes up to him and says, sir, you need to put your seatbelt on. He said, Superman don't need no seatbelt. She quickly replied, Superman doesn't need an airplane either. Which I thought was really, really good. So yeah, just because you're confident in it doesn't make it true. Here's another thing to remember about this issue. There are plenty of brilliant, very well-educated men today who believe the Bible cover to cover. They even believe the cover on their Bible. All right, they believe that the earth is around 6,000 years old, the biblical account of creation, the flood. There are a whole bunch of them. Here are just a few. They exist today. Not only that, but don't forget that most every single scientific discipline was started by Bible-believing guys who believed the creation account, the flood account. There are plenty of people, plenty of brilliant, and I encourage you sometime, look at the resumes of some of the scientists in the past. These guys, all the degrees they had, the languages they spoke, it's amazing. I think they were smarter than we are. That's a different issue, but they're amazingly smart. They believe the Bible. And they started all these different scientific disciplines, made all types of great discoveries. I love this quote from Isaac Newton. He says this: "There are more sure marks of authenticity in the Bible than in any profane history. I have a fundamental belief in the Bible as the Word of God, written by men who were inspired. I study it daily." So we see plenty of men in the past, in the present, who are brilliant, who believe the Bible. Another thing to keep in mind about science is that it's not always right. In the past, it's been wrong many, many times. Science used to teach that the sun goes around the earth. And yes, that idea did actually start with science. The problem came when the church adopted that idea, and then later on people figured out it wasn't right, and they tried to change it back, which maybe the church should take a cue for today about evolution in millions of years. Science used to teach that bigger objects fall faster than smaller objects, taught that for 2,000 years. Science used to teach if you got sick, you had bad blood. You needed to let the blood out. The barber signs were actually polls for the blood letters. You go get some blood let out. I actually went to a barber one time who actually let my blood out. He cut my ear. Blood was coming out. I put my hand on it, blood on my finger. He put a little baby powder on it. He's like, "Oh, you're okay." Do you realize, though, that when they were bleeding George Washington to death, if they had just read this verse right here, he might still be alive today? Okay, well, yes, all right. He lived longer, okay? Some of y'all thought I was serious, didn't you? I was like that silent hush of embarrassment. Okay, no, just a joke. Yeah, the life of the creatures in the blood. And so that's another issue. Science can be wrong. And then the two things that we've talked about already. First of all, again, the idea of millions of years evolution came from not new evidence, but a new worldview. And that's another reason why so many scientists can be wrong, having the wrong worldview. And as we've said multiple times, with this issue of uniformitarianism and naturalism, if you start with the wrong assumptions, you get the wrong conclusions. How fast was that calf going? All right? But beyond the worldview issue, it goes one step further than that. The Bible tells us very clearly it's actually a heart issue. That's what it really is. Romans 1, 21, 23 tells us, or through 23, "For although they knew God, they neither glorified him as God nor gave thanks to him. But their thinking became futile, and their foolish hearts were darkened. Although they claimed to be wise, they became fools, and exchanged the glory of the immortal God for images made to look like mortal man and birds and animals and reptiles." Everybody knows there's a God. That's kind of built into us. Atheists know there's a God. You don't get that mad at somebody who does not exist. All right? They know there's a God, but there's a choosing of rejection, the rebellion of the heart. And again, we need to remember that no matter how smart you are, how many PhDs you have, they don't change your heart. 2 Peter tells us, we've seen this already, that the scoffers are willingly forget. They are willingly ignorant. They choose to reject the Word of God. They choose to reject the creation account and the flood. Actually, this reminds me, I'll sum up with this. I heard this creation speaker, and he was talking about, he gave a talk, and afterwards a pastor came down who's committed to the idea of millions of years. And he came down to him and said, "But surely the majority can't be wrong." And he quoted to him this verse. He said, "Well, the Bible tells us that broad is the way led to destruction, that many are on that way, and that there's only a few who find the narrow road." But he said, "Surely the majority can't be wrong." He said, "Well, but the Bible tells us the heart is deceitful, and it's wicked, and who can know it?" But the guy replied, "Surely the majority can't be wrong." He said, but men love darkness rather than light. He said, "But surely the majority can't be wrong." Finally, the guy got frustrated and said, "Do you realize that the majority of scientists did not survive the flood of Noah's day?" Which is a good point. The majority can most definitely be wrong, and we should not be afraid to stand on the authority of God's word. As we've seen, when you do that, you do have answers. And that leads us we made it on time, which is a miracle in itself. Thank you, Lord. Next week, dinosaurs. One of everybody's absolute favorites, and it is a good one. So look forward to seeing you guys back here then. If you want to talk, come on down after the prayer. Let's pray. Heavenly Father, God, we thank you for your word. We thank you for you. We thank you for what you have done around us, in us, and continue to do through us. God, draw us closer to yourself. Use us to magnify your name, to glorify you. And Lord, help us to love you with all our hearts. We pray in Jesus' name. Amen.